Hello and welcome to today's webinar, Architecting a Secure, Highly Available Kubernetes Data Service Platform for Red Hat OpenShift. Thanks so much for joining us on the webinar. This event is presented in partnership with our friends from Portworx, Red Hat, and Intel. Before we get started, there's just a few things that you should know about the event today. First off, I should mention my name is David Davis from Actual Tech Media, and I'm excited to be serving as the moderator. As always with our events here at Actual Tech Media, we want these to be educational. We want to help solve your real world challenges. And so we encourage your questions there in the questions pane of your audience console. Many of you have already said greetings, hello, good morning, good afternoon from wherever you are across the United States and around the world. So thank you for that. But we also want your technical questions on the topic. So as the presentation goes on today, just drop your questions there in the questions pane of your audience console, and we'll be taking your questions live at the end of the event. So keep those questions coming. We also encourage you to check out the handouts tab for additional resources from Intel, Portworx, and Red Hat. At the end of the webinar, it'll be my pleasure to announce the winner of our Amazon $300 gift card. If you're watching this on demand or recorded, of course, that drawing would have already occurred. The products or the prize terms and conditions can be found right there in the handouts tab of your audience console. And then to help further encourage your questions here on the live event, maybe shake some questions loose if you're not quite sure if you should ask. We also have our best question prize today for an additional $50 Amazon gift card. If you're watching this on demand, of course, that drawing has already occurred and the prize terms are there in the handouts tab. We'll be selecting the best question prize winner after the event. All right, so with that housekeeping information out of the way, it's now my pleasure to introduce you to today's expert presenters. Welcome to Matt Levan, Senior Solutions Engineer at Portworx, Mayur Shetty, Global Solutions Architect at Red Hat, and Raghu Murthy, Director and Principal Engineer at Intel. Matt, Mayur, and Raghu, it's great to have you on. I'll hand it off to you. Take it away.
Hello, everyone. Thanks for joining the call today. Today, we are here to talk about an exciting topic, architecting a secure, highly available Kubernetes data services platform for Red Hat OpenShift on AWS. Let me introduce the speakers here. This is Raghu Murthy. I'm a Director and Principal Engineer at Intel. I'm joined here by Mayur Shetty, Principal Solutions Architect at Red Hat, and Matt Levan, Senior Solution Engineer at Portworx. Before we jump into the topic, I wanted to just frame the broader topic and the overall theme that we're really driving towards, which is this concept of software-defined and silicon-enhanced. Intel and Red Hat have been working together for the last couple of decades now. And there's this strong trend towards the software-defined. Everything is becoming software-defined. Started with compute, then went into networking and then into storage, right? Pretty much everything is being software-defined, and that the architecture for that software-defined framework, the platform, is the underpinning of that is Intel's kind of silicon capabilities that really enhances this whole capability of software-defined. So jumping into that, if you look at the slide from the bottom up here, right, the main building blocks that Intel produces to get to this to get to this architecture is all the underpinning technologies on the compute, networking, network transformation, the storage architecture transformation. All of those capabilities are the building blocks that then is used to build our platforms, be it our traditional OEM platforms with our partners like Dell, Lenovo, HP, and others, or our CSP, our hyperscaler partners like AWS, IBM Cloud, Azure, and others, and really transforming this from an edge to cloud, where increasingly our edge partners are also becoming software defined, all the edge compute network and the multi-access edge controls and others. And this combination is what is driving our, and working with our ecosystem partners is really driving the foundation for an open hybrid cloud, that Red Hat and Intel have been partnering on for decades. With that, let me jump specifically into one of our, the main partners here, AWS, that Intel has been collaborating for over 15 years in engineering a variety of different, pretty much the whole platform from, if you look at it from, all the instances that we have with AWS, from the cloud instances to the other end, to the edge instances like Outpost and Wavelength, and also the devices like that you see, the Echo devices and other devices, right? So the entire partnership, with AWS has been really cornerstone of what's driven the cloud adoption. And with that, making sure that we have a shared customer passion, as well as really making sure that it is at a the high performance that is expected of our customers, along with the really cost-effective solutions, is what we've been driving, and making sure that it is it has a world-class supply chain and a secure supply chain at it. With that, I want to jump into and just give a little context on the extent of our collaboration with AWS that we have. So if you look at this chart here on the left, all the different generations of Intel hardware and the instances that you see, from general purpose compute to compute optimized to memory optimized to accelerator compute for AI and HPC type workloads, and the storage optimized workloads. We have the entire spectrum of compute platforms that AWS offers, with over 275 Intel instances that are available across all regions and availability zones. Okay, and just to highlight a few of them, our latest instances are with our third generation Xeon platform called Ice Lake. We have these instances, compute instances for the C6i instances, as well as the R6i instances are available, for the performance, for compute that need that high compute performances. And a special call out for something called Habana, which is our deep learning accelerator that was launched last year, with for customers that want the deep learning, high performance deep learning capability. Okay. And this year, we actually launched our EC2 R7 instance. This is based on our upcoming launch that we'll be making with our fourth generation Xeon scalable processor, also called Sapphire Rapids. Okay, so obviously this is an eye chart, but gives you a spectrum of all the different instances that are available on Intel platforms with AWS. Okay, with that, I wanted to get to the topic of the discussion today, which is the collaboration between Portworx, Red Hat, and Intel in really creating a platform, an open platform that allows enterprises to scale, secure, that is able to deploy secure Kubernetes applications and platforms and databases anywhere. With that, let me hand it over to Mayur.
Thanks, Raghu. So what we hear from customers around the world is that their ability to create value for their end customers, both internal and external, depends on their ability to deliver applications and services faster. Now, containers and Kubernetes has fundamentally enabled DevOps, microservices, AI/ML workloads, and also cloud-native application development. And we'd like to believe that in Red Hat that OpenShift is the best platform to deliver applications across the hybrid cloud. So installing Kubernetes and playing around with it, for many, it's not that big an issue. But Kubernetes as a platform to deploy your enterprise applications, your business critical applications, and that takes a bit more. So while it's not actually that hard to download and install Kubernetes, getting it really ready for production to run critical applications requires a bunch of services around it to make it production ready. So here are a couple of examples. Just take identity management. So with Kubernetes, you will be providing access to your critical internal systems, to your employees, to your partners, to your customers, and you need to adhere to some security rules established by your organization. And the way to do that is to write an integration between Kubernetes and your company provided LDAP. And that requires a fair bit of DEX knowledge. DEX is an open source identity system. It requires a fairly good understanding of Kubernetes and integrating it with LDAP. Similarly, you'll also need to hook up Prometheus. Now, this is an open source monitoring and alerting tool that will give you a good view of not only your services, but also your system. On this slide, you'll see a number of such bullets, and someone in the organization needs to execute and needs to make sure that these are in place for a production ready or a day two operations of your Kubernetes cluster. So in Red Hat, we see a lot of activities happening in Kubernetes, but it seldom ends there. It's just a matter of time. Like I said, someone in the organization says, hey, my application is acting a bit strange. Can I get to see the logs? Or someone will come in and say, I want to do some CI/CD testing. How can you help me set it up? And the truth is there's not a single Kubernetes cluster in production that does not have all these services or features in one shape or another. And again, these need not be open source projects, but you need to have at least the functions that these projects and services do. So now all of a sudden, you as a Kubernetes administrator are managing all these open source tools and projects that you're using in your cluster. And each of them, they come with their own skill set, their area of expertise. They even have their own release cadence. So now all of a sudden, you're juggling multiple balls where each of them have their own nuances, and you're trying to make sure that they don't come all crashing down. So what we do is we take OpenShift, and with OpenShift, we provide all these tools and projects. That is, we take Kubernetes, we take all the popular tools, we package them together as one organic platform. We do all the integration work. We do a lot of hardening. We do a lot of testing. We provide defect remediation. We provide security improvements, and then we release it as an OpenShift version. So, like I said, OpenShift provides a turnkey platform for deploying applications and services on Kubernetes. So the blue boxes you see here are the OpenShift provided services, and the blue boxes are the native Kubernetes services, and the green boxes are the OpenShift provided services that we've added to Kubernetes to make it enterprise ready. Some of the features and services that we've added is like Kibana to display the log data, and which is collected by FluentD, and it's indexed by Elasticsearch. Also, with OpenShift, you get a local registry to save your container images or your services images. One question we get quite often from customers is, what's a tool for monitoring the health of my systems? So with OpenShift, we provide Prometheus for monitoring not only your system, but also the services, also for monitoring your services, which come along with deployment of OpenShift. And again, Grafana is there to analyze and visualize all the metrics. So in addition, from what we've learned with OpenShift, we have developer and admin tools that we bundle along with ROSA and Kubernetes to make it production ready. And the question again comes up is why is OpenShift hybrid? And the reason is because OpenShift can run on any platform. And that means it can run on your data centers, that's on-prem, on bare metal, or on virtualization platform like Red Hat virtualization or VMware for that matter, or even on OpenStack, which is a private cloud. Now you can even run OpenShift on Outpost or local zones, and even on the edge servers. So all that put together makes OpenShift truly hybrid. So again, when working with AWS, Red Hat and AWS have been working for a long time, just like we've been working with Intel on the RHEL front. But again, with OpenShift, we've been working with AWS for a pretty long time, right? From OpenShift, the earlier version of OpenShift, which is OpenShift 3 onwards, and we had OpenShift dedicated back then. So if you go, OpenShift comes in two forms. One is the self-managed, and one is basically the managed. Self-managed is what you get on premises, which is OpenShift Container Platform, where it's deployed and managed by you, the end customer. Also on AWS, you can get the self-managed option, where you are basically going to install the cluster and manage it yourself. And now with ROSA, which is Red Hat OpenShift on AWS, you get a fully managed OpenShift cluster, which is a native AWS offering. And this offering is jointly supported by Red Hat and AWS. In the next couple of slides, I'm going to talk a little bit more on ROSA itself. So why are customers looking for managed OpenShift? And this basically falls into one of these categories. The first one being faster time to value. And this is the most important one, because with a self-managed one, your time to get your hands on keyboard, it's fairly long. It takes sometimes a few days to even weeks. But with ROSA, a fully production cluster is up and running in 40 minutes. And that's because we take a lot of the activities that go along with delivering the cluster, like the day one activities and the day two activities. And this allows the customers to operate a lot more efficiently. And the same resources that they would have put into the plumbing of the cluster and the administration of the cluster is now looking at higher values activities like their applications, their data, and delivering true value to their end customers in the form of their services. So in addition, we also monitor the cluster, we do the updates, we do the upgrades. So in that way, the customer can focus on their value or their end service. So again, what we also provide is we provide 24/7 support. And like I said, this support, for support, the customer has the flexibility to call either Red Hat or AWS. And if the issue is actually on the infrastructure side, it will be seamlessly transferred to the AWS side, or if it's on the OpenShift side, vice versa, the ticket will be dealt by Red Hat. But the customer can pick up and the phone and call any support organization that they are comfortable or have worked with in the past. Also, like I said, the cluster is updated and upgraded by the Red Hat SREs. It's constantly monitored. And so for that, we provide a 99.95 financially backed SLA. So like I said, we do all the monitoring of the system, of the hardware, the networking, the storage, the platform itself, and many a times the application too. So when I say the application, what I mean is the application image. If the application image is using a Red Hat universal base image, the application, like I said, it's your service, so you would be responsible for the application on the whole. Here on this slide, what you're seeing is a self-managed OpenShift cluster on AWS. What this means is you have deployed the cluster, you have basically taken care of the high availability that comes along with the cluster, the networking, the load balancers, the DNS, and all this is done along with you managing your application or the service that you're providing. The OpenShift installer does provide some guardrails to help you create a cluster following the best practices. But at the end of the day, it's you or the customer's responsibility to make sure that this cluster is up and running in a production-ready manner. Or you could offload all that to Red Hat and AWS, meaning let us manage them for you, and you as the end customer can focus on what's truly important to you, which is your service or application that's important to your business. Again, if you we have more detailed best practices on what is your responsibility on and what is the customer responsibility. So do feel free to reach out to us, and we will give you a complete detailed list on that. Finally, the screenshot. This is like I said, ROSA is a native AWS service, meaning it's available on the AWS console. Like I said, under containers, you will see that AWS already provides ECS, EKS, and now you have ROSA, Red Hat OpenShift service on AWS. So it's not an apples to apples comparison. So each service provides different values. So if you're looking for a turnkey container or Kubernetes platform, OpenShift is the way to go. And again, this speaks volume about our working relationship with AWS and the value that managed OpenShift or ROSA provides to the end customers. So again, some of the questions for you to take back is, if managed OpenShift is the right option for you, it is to make sure and see that do you have the staff and the skills to manage your Kubernetes clusters? Or do you have the time to take on the responsibility of managing Kubernetes clusters along with all the ecosystem and the tools that are required to run a production-ready cluster? And more importantly, do you have a process in place for all this? Again, if the answer is no, or if you're still wondering whether it's the right thing, please do reach out to us, and we'd be glad to work with you to see and help you get through this process and provide you tools which will tell you that why ROSA is the right option for managed OpenShift. So at this point, I will pass on the mic to Matt to talk about Portworx and how Portworx integrates with ROSA. Thank you.
Thank you, Raghu, for your introduction from Intel, and Mayur for the details on Red Hat OpenShift on Amazon AWS. So, ROSA and OpenShift is built upon Kubernetes, as Mayur talked about, but, Kubernetes solves the application orchestration problem. It doesn't solve your data management and data protection problems. You don't get container-granular volume provisioning and high availability. You don't get data encryption and security out of the box. One thing we always hear is that we need to think about, when you start looking at enterprise-grade applications, which you're going to want to run on ROSA, you need to have business continuity and disaster recovery along with backup and recovery. A lot of times you'll hear things like snapshots are not backup. They're a quick way to be able to restore, but you don't have both a offsite copy or another backup that's available for use there. And another thing that we really bring to the table here is automated storage monitoring and management. Mayur talked about all the features that are baked into OpenShift and specifically ROSA around monitoring and metering. We can integrate into those features and be able to help you give day two operations to your storage management and provisioning. All very important things that are available to you with Portworx. So, we talked about what are the challenges around Kubernetes and storage. Well, what about challenges with cloud native applications and databases? The change over to microservices, you're now going to have heterogeneous databases, each with its own way of being deployed, each different way of being managed. You have different operating tools and vendors that you're going to work with. And you might not have all the capabilities to be able to manage all those different databases. Slow app development. Kubernetes really gives you the capability to do stateless apps very quickly and easily, but without the right storage management layer underneath, trying to do those stateful apps is not going to be the same. You won't have that same self-service and same ease of use, especially if you're looking at non-native Kubernetes data management platforms where you might have already been designed and built purposely for virtual machines, but it's not going to have that same Kubernetes native self-service that you want to get. And also the lack of availability during outages, right? You need to have a data management platform that takes care of that high availability, including disaster recovery and data protection, which leads into the next. Your traditional backup environments are not going to be built to back up Kubernetes applications. They don't know what actually makes up the application. They may be able to back up the data, but they won't know about those Kubernetes objects that actually make up a Kubernetes application, such as services, deployments, staple sets, all those different things that you need to be able to back up and restore. And then the capability to back up and restore, whether between clouds, between regions, between on-prem and cloud, you need to have that capability to do that backup and restore in both places. And then having compliance, you'll hear 3, 2, 1. You need to have 3 copies of the data on 2 different medium, with one of them being offsite. So that could be having, your data plus a snapshot plus a backup that's been written off to a S3 object store. And then you can add another one in there at the end to have ransomware protection. So having that object be object locked, or set the worm, write once, read many. Sorry about that. But that's some of the capabilities you're going to need for your cloud native applications. And then there's the business outcomes you're going to receive when you look at Portworx. That, like I mentioned, having that capability to have stateful applications that are deployed as needed and be able to fit into an OpenShift or Kubernetes architecture where it's giving self-service to your developers, reducing the time to market for development. You'll be able to easily go from dev to test into production, even using your continuous integration and continuous delivery. Part of that is your improvement in your database productivity, being able to do hybrid cloud, so being able to run on-prem or in AWS, and having that capability to either migrate or replicate or back up and restore between these 2 environments as needed. Another thing is cost, right? One thing Portworx does is we will be able to save you up to 75% of costs. And there's a customer study at the end where we'll talk about how we are able to achieve that for them. And then finally is the fault tolerance, being able to have replicas in multiple availability zones, or replicate in metro regions with an RPO of 0, or replicate between regions asynchronously so that you can handle failure in a single region. These are the business outcomes that we're driving here at Portworx. So Portworx has been the #1 Kubernetes data platform, and it's actually made up of really 3 distinct lines here. So we'll talk primarily about our data management platform. That's the Portworx Enterprise. So that's the #1 platform for storage in Kubernetes. Next is data protection with our Portworx Backup product. So being able to have container-granular backups, whether that's at a namespace level, or you can use labels to define your applications and make sure that your application and all its Kubernetes objects are being backed up properly. And lastly is the new product we launched last year, which is Portworx Data Services, which is a database as a platform. So being able to give self-service delivery of a various amount of databases to your developers so that they don't have to go look and find how to deploy a database. They'll get best-in-class capabilities of being able to deploy those databases into your OpenShift clusters and then make use of them right away. So really giving developer productivity with one click. One thing we do with Portworx Enterprise is being able to scale easily. You can define rules so that you're monitoring the capacity of your storage pools, or you're monitoring the capacity of your stateful data. And when that rule is triggered, it can automatically grow your capacity as needed. So giving a lot of day 2 operations that can be handled after the fact and doesn't have to have a call in the middle of the night to know, hey, I'm running out of capacity on my application. Okay, I need to get on and grow that volume right away. And then being able to easily and protect your data and applications in OpenShift. One thing we like to talk about is that we do run on any infrastructure, so AWS or on-prem or AWS Outposts, any Kubernetes service, so Red Hat OpenShift on AWS or Red Hat OpenShift on-prem. We can run on any of the distribution that you have chosen to use for your deployments. And we just actually announced in KubeCon North America in October a fully managed service for Portworx Enterprise. So this will go very well with Red Hat OpenShift on AWS. If you're already looking for a fully managed Kubernetes distribution, such as ROSA, then Portworx Enterprise fully managed will most likely appeal to you. It's really about, again, speed, time to value, being able to very easily deploy Portworx Enterprise and get that #1 Kubernetes data management platform onto your OpenShift clusters. And then also to, ease operations. It's going to have a single pane of glass that'll make it easy for you to monitor and be able to react to any issues in your OpenShift clusters. So you'll be able to visually see capacity and use, if there's any errors, things that may need to be taken care of sooner than later. And also having just like that day 0, day 2 operations, the installation through being able to monitor and meter your capacity on demand through a single pane of glass. And again, the single pane of glass is going to be cloud hosted, so you'll be able to access it anywhere. You'll be able to see all your different clusters in one place and really be able to have a good experience of being able to manage all these features that are given to you. At Portworx, we're really proud to be the #1 Kubernetes storage for the 3rd year in a row by GigaOM. And that's through leading in innovation and development and really having a developer and administrator focused approach, having very good customer service, being able to respond and add features that are really important to our customers. And Pure Storage has been recognized as a leader in enterprise data storage. So Pure has things like the flash array, FlashBlade, things that you typically see in your data center. You may already have it, and it's a good starting point for being able to get started with OpenShift. So again, some of the features, coming back to them, right? The things that we give ROSA are disaster recovery and high availability. So having that capability to do multi-availability zones, multi-cloud, multi-region, HA and DR, having 0 RPO for Kubernetes applications. So if you're in a metro region, you'll be able to have 2 clusters that are synchronously replicating data. And if there were something to happen in one cluster, you'll be able to easily bring up your applications on another one. And then again, being able to back up and restore. So being able to back up from any location, whether it's on-prem or a ROSA cluster in one region to another region, you can easily back up your applications and recover them in another location. Data migration. So this is around being able to either use Portworx Enterprise to do a one-time migration from on-prem to ROSA, or between ROSA clusters. You can just replicate the data and its Kubernetes objects between those 2 sites. It allows for cross-cloud, cross-region, and cross-zone migrations. And optimize cost and performance. One of the things that Portworx Enterprise does by default is thin provision volumes. This leads to being able to right-size the capacity as needed. As I mentioned, we have capacity management tools that integrate with OpenShift and be able to monitor your storage pool. So you might be able to start out small, but then use the tools that are built into Red Hat OpenShift on AWS to expand capacity on your storage pool, expand the number of worker nodes. Maybe you need to grow horizontally, or you need to grow vertically. So all these capabilities that are built into OpenShift, we are going to leverage to give and make your day two operations easier. Which brings me to a point about Amazon EBS, so the Elastic Block Storage. So you can use Amazon EBS for your containers, but there are some things that really it's not going to do very well. It can only do asynchronous replication at a volume level. So you're not going to get the app plus data replicating between your sites. You would have to do it in another way to get the application data. Then provisioning. This is really where the cost savings comes in. If you provision more than you needed at the start of when you deployed your application, well, you're paying for that capacity when you may not be using it right away. Maybe you've deployed the capacity forward thinking out to a year. Well, that's a lot of costs that you might not need to be paying right now. You could do it later as you grow and those volumes grow. EBS is limited to the number of volumes per host. So if you were to run too many stateful applications per host, well, now you have to add more hosts. Whereas with Portworx, we can do up to 1,024 volumes per host. So that means there's a lot more stateful applications that could be running on that host than if you were just using EBS directly. Resize on demand right now it is offline only, whereas Portworx can do that online. We also have quality of service and COS. This allows for taking care of noisy neighbor. Maybe an application is going to use too much throughput or IOPS, and you don't want it to have to do that. Just run away with the volume and maybe cause issues. So you can set a quality of service on that. And something that really resonates with people and customers is cross AZ support. So if you want a truly enterprise OpenShift cluster, it's not going to be deployed in one availability zone. It'll be deployed across multiple availability zones, and you need a storage that can cross those AZs, being able to give you that high availability. So in case of a node failing in one availability zone, well, the application is just going to move to another AZ, and your data is going to be available. You won't have to deal with migrating that EBS between AZs. Being able to do fast failover is another one. Something that Kubernetes has been working on for a very long time is if a node were to fail and there was no mechanism available to notify that node was failed, it would take a while for a node, that application to actually terminate on the failed node and be moved over. Kubernetes is working on a solution for that now, but we've had that for a while. And also additionally is having IO profiles. So you have your choice of choosing if it's a database, auto, sequential, random. So if you know your application workload and what is the right fit for the IO profile, you can define that in a storage class and have your developers make use of it. Right size, performance optimized, persistent volumes, like I mentioned, is you can provision more than you need at the time, but because it is then provisioned, your storage pool is not going to be showing that capacity. It's only going to be using what is actually in use at the time, and you'll be able to right size those applications. Oh, and data portability. I mean, this is very similar to the multi-AZ support, but really being able to move volumes between and applications between worker nodes on a as needed per basis. So if OpenShift is going through an upgrade cycle, it's going to put those nodes into maintenance mode so that the upgrade can occur, and it'll just easily move that application from that worker node as it's going through its upgrade process to a node that's online. The OpenShift upgrade process is so well done and easy to use, especially if you have ROSA, where it'll be managed by Red Hat and AWS. You won't even see any issues with your applications during that time. So here's a case study, one of our customers, CHD Healthcare. They were actually needing to speed up development and time to bring applications to market. They were actually migrating from on-prem to the cloud and needed a solution that would give them both speed of development and save them money. This is a use case where they were able to save $5,000 per month in streaming and management costs by leveraging Portworx and the benefits we bring. And one thing is they really enjoyed the support from Portworx engineers. Here's a quote from Reed. With Portworx in place, we can continue to play our part in helping hospitals and medical institutions deliver modern care services across the United States for years to come. Really good use case study from CHD on how Portworx was able to give them the capabilities to make use of the cloud and really speed up their development cycles. And next we have Audi. So this is actually a cost benefit value here. They were able to actually reduce their cloud storage bill by 60%. And also were able to improve Kubernetes storage performance and improve operational reliability and upgrade support. So they were looking for a Kubernetes data management platform that would give them even better reliability, performance, support, and pricing compared to their legacy NAS that they were using. And a quote from Sven is, Portworx saves us time and money by providing more reliable tooling to our customers. So lastly, we'll go into a demo. So this is an example of what Portworx Enterprise can bring to you. And that is the capability to do synchronous and asynchronous disaster recovery. So if you are coming from a legacy storage mindset, you're used to this. This was a standard way to design your legacy applications. You would do a 2 data center synchronous replication in a metro region with a third site being in another region, which you would asynchronously replicate to. So I'm going to do this at about 1.25 times. So hopefully I can keep up with it. So the first thing I'm going to show here is, so this is, and again, an example of the capabilities with Portworx Enterprise. And this is 2 3-node worker node clusters that are running in Amazon Web Services, AWS. So the first thing I want to show here is I'm going to exec into the Portworx cloud node and show that, Portworx is up and operational. But what is important to show here is, because this is a synchronous replication, even though it is 2 different Kubernetes clusters, I actually have 6 nodes because Portworx is running in a single cluster. So it'll appear as a single cluster. Here, I'm going to show the cluster domain status using Stork. Stork is our open source storage orchestration tool. And you'll see that cluster 1 and cluster 2 were in sync. Here is the async cluster that is running in US West 2. The other two clusters are running in US East 1. So again, I'm going to exec into the Portworx pod and show how it is configured. Again, I'm going to run Pixie CTL to show that the Portworx cluster is online, but in this case, there are only 3 nodes because this is going to be an asynchronous replication. It's not going to see the other nodes. And here, I'm just validating that there are no objects available in the demo namespace. There's nothing running in demo namespace. So let's go back to our synchronous cluster, and I'm going to create a cluster pair for the sync relationship, and also a cluster pair for the asynchronous relationship. So here I'm using creating the sync DR and then the async DR replication cluster pairs. Next, I'll showcase the cluster pairs, and you'll notice that the storage status on sync DR is not provided. That's because it is in a synchronous relationship, so it is a single cluster as it appears here. But the async DR is in a storage status ready, and schedule status is ready for both. Here, I'm going to show a demo policy, schedule policy. And what you're going to see here is that it is defined to run every 15 minutes. So as you'll see here, it's scheduled for every 15 minutes. So this is to define that we'll use in the next steps on creating this. But right now, we're going to deploy a demo application. So we have a Portworx barbecue application. So first, we're going to deploy MongoDB as a deployment, and it's going to create a persistent volume claim on the storage class px-db. Next, we're going to deploy the web applications. So this is going to make a 3 replica deployment of the barbecue web application. So next, we just have to wait for all the applications to be up and running as normal. And now we'll access the Portworx barbecue ordering system. Well, first we have to register. So here we're registering as Bob and Shah. And now we're going to place an order. So the first thing we're going to order is a grilled cauliflower steaks with some sides. And let's add some more to our order. So next we'll do smoked chicken, again with some more sides, applesauce, coleslaw, and a tea. Well, now we can see our order history. You'll see that we have 2 orders in place and that they've been there. So let's get ready to create our migration schedules. So migration schedules are going to create migrations. So we create one for the sync migration and the async migration. So we'll check on to make sure that they've been created. And then next, we're going to check on the migrations themselves, and we'll watch them occur. So you'll see here the sync migration is already done. So it didn't have to replicate the volumes. It only had to replicate the Kubernetes resources. So the deployments, the services, and the persistent volume claim information. But the asynchronous is going to take a while longer because it's now replicating the persistent volume asynchronously to the US West 2 locations. So we'll wait for this to get finished. When all the resources have been replicated, we can now move on to simulating a failure. So the first thing we're going to do is we're going to deactivate cluster 1. So this is making it so that cluster 1 won't be in sync with cluster 2 anymore, because we don't want any changes to occur because we're going to take down the application on cluster 1. So we do that by scaling down the applications. So we're going to scale down Mongo to 0 and the web application down to 0. So now that we've done that, we're going to go over to the second cluster in the Metro synchronous cluster and also show that the application's offline and not available anymore. So let's go over to the second cluster. And now we're going to activate the migrations. What this is going to do is it's going to scale the replicas of Mongo and PX Barbecue Web up to what they should be running as, in this case 3. So we need to wait a little while. Again, this is a synchronous relationship. So the data that was written on cluster 1 was synchronously replicated to cluster 2. We just need to wait for the applications to come online. Primarily, Mongo needs to be online prior to the web application be able to access it. Mongo's online, so the web applications are now online. So next we'll go log into that Portworx barbecue application connected to cluster 2. As you see here, we'll log in again as Bob and Shah. And then we'll check the order status history. And in the history, you'll see we have grilled cauliflower steaks and smoked chicken. So we're able to move between cluster 1 and cluster 2 very easily. Now we're going to do asynchronous simulation. So we're going to simulate failure of the region and go over to US West 2. First, we need to suspend the migration schedule. Again, we don't want any changes that are written here to be replicated. This would not obviously occur if there were true failure. This is simulation. So we are now going to show recovering our applications in US West 2. So again, we're going to activate this migrations and bring up the replicas of the deployments. And once these deployments are online, we'll actually go check out the application again and see. So, but just to showcase, we showed earlier that there were no objects in demo. There was no PVC, there was no deployments or services. So all that was copied as part of the replication factor. And then again, we're going to log in and then be able to showcase that the orders are done. So that is the end of the demo. I don't know, get back. So now we'll turn it over to Q&A. So if there are any questions, we'll be happy to answer them. And thank you for attending the webinar. I hope this was useful. You learned a lot about Red Hat and OpenShift on AWS, how Intel is helping run different instances and what capabilities they're bringing and what Portworx brings to the table. Thank you.
All right, great presentation. Thank you so much, Matt, Mayur, and Raghu. Really appreciate that. Really appreciate the excellent demo as well. Always love seeing products in action. Yeah, it's now time to kick off our Q&A. If you have a question for Portworx, Red Hat, or Intel, now is the time to get it in. I'm going to go ahead and start with the first question I see here. This one came in from Matt. They're asking, are there any Portworx products available on the AWS marketplace, similar to how Red Hat OpenShift on AWS is? Matt?
Yeah, that's correct. We also have Portworx Enterprise and Portworx Backup are both available on AWS Marketplace. So if that is your preferred way of getting the products here, it is available.
Excellent. All right, that's good to know. That makes deployment just super easy in AWS. So really cool, really good to know. Let's see, here's another good one. This one for you, Mayur. They're wanting to know, let's see, you mentioned that Red Hat's SREs update and upgrade the ROSA cluster, but can we as a customer or end user have control on how or on when the updates and upgrades are done to the ROSA cluster? How does that work?
Yeah, that's a great question. So ROSA is a fully managed OpenShift cluster. So meaning Red Hat SREs will manage it for you. In case a node goes down, they will fix the issue, and also if there are any updates and upgrades that have to be applied to the cluster, they would do it. But I understand that some customers, say for example, it's Black Friday weekend, and they want to kind of not have an update or upgrade happen during that time, because that's a busy time for them and for their service. So they would like to control a day or time which is after that for the updates and upgrades. And yes, they can very well do that. They can go to Red Hat Hybrid Cloud Console, and they can specify the exact time and date when they want the update and upgrade to happen. So even though it's a fully managed cluster, the customers do have that functionality or granularity where they can control when they want it. But I would highly recommend leveraging the automatic updates and upgrades provided by the SREs. But if you do have a situation where you don't want it to happen at a particular day or something, so then you can specify when you want it to happen. Hope that answers the question.
Yeah, that sounds great. It's like the best of both worlds right there. You've got it automated, so you don't have to worry about it. But if you do want some control, you still have that as well.
Right.
Let's see, there's a good question here about cost. What are the cost savings realized with ROSA and Portworx Enterprise? Mayur, you want to start with that one?
Yeah, so the ROSA is basically available as a pay-as-you-go model. So you can do that. And so basically you're consuming it from the AWS console, and you get a single bill from AWS. But now you can also use hybrid commit spends and procure it from the marketplace itself. Also, Red Hat has put some programs in place. The hybrid commit spend is a very popular program, and this provides the customers a lot of flexibility in terms of how they want to purchase and deploy Red Hat products. I mean, this could be on-prem directly, or it could be on the cloud. So from a customer point of view, there is a commitment towards like a 3-year spend commitment, and that's part of the program. And then what it gives them is the flexibility to either consume the product on premises or on the public cloud. And again, all this comes with a fair amount of discounting.
Very nice. Yeah, Matt, did you want to add anything to that?
Yeah, so from Portworx perspective, we really bring cost savings through, having a default of thin provisioning, having a lot of automated storage capacity management so that you can right size your storage pool or your volumes so that you can start small and grow as you come along and make more use of the capacity. So those are really like the things that Portworx does to give capabilities for cost savings in AWS.
Excellent. Yeah, and every company out there could use a little cost savings, I'm sure. Sounds like a great benefit to the solution here. Let's see, maybe time for just one more question. Mayur, they're asking, can we access other AWS services like RDS, SageMaker from within ROSA?
Yeah, absolutely. So ROSA is a native AWS service. It's available on the console. So being a native AWS service, ROSA can directly access the other AWS services offered by AWS. Meaning, if there are operators in place, so you go to the ROSA console, you go to the operator, and there are AWS operators which will allow you to connect directly to other services like RDS, it could be EFS file system, SageMaker, and the list goes on. So yes, absolutely. So because being a native AWS service, it allows you to connect to other services seamlessly.
Excellent. Excellent. All right. Well, I'm afraid we reached the top of the hour. We're out of time here in our webinar. Matt, Mayur, and Raghu, really great presentation, cool demo. Thank you so much for being on the event today.
Thanks for having us.
Excellent.
Yes, thank you for having us.
Absolutely. And thank you to our friends over at Portworx, Red Hat, and Intel for supporting us on the event. And of course, big thank you to the Actual Tech Media audience for joining us on the webinar. Don't forget about the resources there in the handouts tab. There are links to get started with Intel, Portworx, and Red Hat for additional information. And of course, we talked about this being available over in the AWS marketplace as well. All right, so with that, it's now time to announce the winner of today's Amazon $300 gift card. This is going out to Mario Mesa from Texas. Congratulations, Mario Mesa from Texas. and we'll be reaching out to our best question prize winner as well. Thank you to everyone who joined us on the webinar today. I hope you learned a lot, and I hope you have a great day. We'll see you next time. Bye-bye.